The basics. What makes a tornado form? To understand why tornadoes last longer, we need to look at how they form. Tornadoes usually begin inside powerful thunderstorms called supercells, rotating storm systems with a deep, persistent updraft known as a mesocyclone. Warm, moist air from the ground rises and meets cold, dry air aloft. This clash creates instability and wind shear, changes in wind direction and speed with height, which causes the air to start spinning horizontally. When a strong updraft tilts that rotation vertically and stretches it, it can form a funnel that touches the ground, a tornado. But here's the key. The same ingredients that create tornadoes also control how long they survive. The power source, supercell longevity. The lifespan of a tornado is often tied directly to the lifespan of its parent storm. Supercells are extremely organized and can persist for several hours if conditions stay favorable. They continuously draw in warm, moist air and expel cold air through downdrafts, maintaining a delicate balance that keeps them alive. If that supercell remains stable and strong, the tornado underneath it can also stay strong for a long time. On the other hand, weaker, short-lived thunderstorms tend to lose structure quickly. When the updraft weakens or gets cut off by cool air, the tornado starves and dissipates within minutes. So, long-lived tornadoes almost always come from long-lived, powerful supercells. The role of atmospheric conditions. Tornado duration also depends heavily on the surrounding environment. The most favorable setup includes high instability, strong wind shear, and plenty of low-level moisture. These ingredients allow rotating updrafts to stay tight and strong, feeding the tornado below. When the atmosphere provides sustained energy, especially when warm, moist air keeps flowing into the storm, the tornado can stay alive for a long time. But if those conditions change, say the storm moves into cooler or drier air, the energy source gets cut off, and the tornado collapses quickly. This is why some tornadoes seem to die as soon as they move over different terrain or leave their ideal environment. The balance between updraft and downdraft. Every tornado exists in a fragile balance between rising warm air, updraft, and sinking cool air, downdraft. For a tornado to last, the updraft must stay dominant and prevent the downdraft from cutting off its energy supply. If the downdraft wraps around and chokes the inflow of warm, moist air, the tornado weakens and dies. In long-lived tornadoes, this balance stays intact for extended periods. The inflow remains steady, and the downdraft doesn't overpower the system. In contrast, short-lived tornadoes lose that balance quickly. Either the updraft weakens or the downdraft becomes too strong, breaking the cycle. The ground factor, terrain and surface conditions. Believe it or not, the surface below a tornado can also influence its longevity. Flat, open areas like the Great Plains in the United States tend to allow tornadoes to last longer. The lack of major obstructions lets inflow air feed the storm easily and keeps the structure stable. However, when tornadoes move over rough terrain, forests, or mountains, they often weaken. The uneven surface disrupts airflow into the storm, reducing the tornado's strength and lifespan. This is one reason the longest-lasting tornadoes are often found in flat regions like Tornado Alley. Multiple vortex structures and stability. Some of the most long-lived tornadoes develop multiple vortex structures, smaller tornadoes rotating around a common center. This setup actually stabilizes the system, allowing it to redistribute energy more efficiently. It prevents the main vortex from collapsing too quickly and can extend the tornado's life significantly. These multi-vortex systems are often seen in the most violent, long-lasting tornadoes, like the 2011 Joplin tornado or the 2013 El Reno tornado. Movement and speed of the parent storm. Another factor is the speed and path of the parent storm. When a supercell moves steadily and maintains a consistent direction, its inflow region stays undisturbed. The tornado beneath it can feed continuously and remain stable. But if the storm changes direction rapidly or slows down, it can disrupt the inflow and cause the tornado to dissipate. So, smoother storm motion often equals longer tornado duration. Tornado families and cyclic supercells. Sometimes, what appears to be one long-lived tornado is actually a tornado family, a series of twisters produced one after another by the same parent storm. This happens with cyclic supercells, which repeatedly form new mesocyclones and new tornadoes as old ones die out. Each individual tornado might last only 15 to 30 minutes, but the overall system can produce continuous tornado activity for several hours. This makes it seem like one tornado has lasted for an incredibly long time, when in reality, multiple separate tornadoes are forming in sequence. Atmospheric boundaries and interaction tornadoes often form and sustain themselves along boundaries, zones where two different air masses meet. If a supercell stays near one of these boundaries, like a warm front or dry line, it can keep tapping into unstable air, helping the tornado last much longer. However, once the storm moves away from that boundary, it loses its source of rotation and moisture, leading to a quicker death. The rarity of long-track tornadoes. Long-lived tornadoes, sometimes called long-track tornadoes, are extremely rare. Most tornadoes last less than 10 minutes and travel only a few miles. But in some extreme cases, tornadoes have lasted over an hour and traveled more than 100 miles. For example, the Tri-State tornado of 1925 holds the record as the longest-lasting tornado in history. It stayed on the ground for about 3.5 hours, covering 219 miles across Missouri, Illinois, and Indiana, killing nearly 700 people. This tornado's extraordinary lifespan was due to nearly perfect conditions: a massive, steady supercell, incredible atmospheric instability, and strong wind shear that remained consistent over a huge area. The role of climate and season. Seasonal and regional climate patterns also affect tornado duration. Spring and early summer in the U.S. bring the best combination of ingredients: high humidity, strong jet stream winds, and frequent supercells. These conditions support longer-lasting tornadoes. In contrast, tornadoes in cooler or less humid regions tend to be weaker and shorter-lived, simply because they lack the sustained energy needed to keep spinning. Tornado decay. Why they eventually die. Even the most powerful tornadoes eventually lose energy. As the supercell's structure changes, the inflow of warm, moist air gets cut off, and the tornado starts to rope out, becoming thinner and weaker before finally dissipating. Sometimes, a storm's cold outflow undercuts the updraft, cutting off the tornado's supply line. Other times, the mesocyclone shifts location within the storm, moving away from the tornado and leaving it to fade out. This decay process can happen quickly, even after a long lifespan, once the internal balance collapses. Tornado research and future prediction meteorologists are still studying why some tornadoes last so long while others fade almost instantly. Advanced radar systems and computer simulations have helped scientists understand that the longevity of a tornado depends on how well its parent storm maintains rotation and inflow. Projects like Vortex, verification of the origins of rotation in tornadoes experiment, have shown that subtle shifts in temperature, humidity, and wind direction can determine whether a tornado lasts 5 minutes or 2 hours. As technology improves, researchers hope to better predict not only when a tornado will form, but also how long it might last, a key step in improving warning times and saving lives. Famous long-lasting tornadoes in history. Let's look at a few examples of tornadoes that stood the test of time. Tri-State tornado, 1925, 3.5 hours, 219 miles, one of the deadliest in history. Tuscaloosa-Birmingham tornado, 2011, lasted over 1.5 hours and traveled 80 miles. El Reno tornado, 2013, lasted around 40 minutes with a record-breaking 2.6-mile width, the widest ever recorded. Each of these tornadoes formed under incredibly stable high-energy conditions that allowed them to sustain rotation far longer than normal storms.